Okay. Can you all see my screen? It's showing week 8, yeah, SPSS data analysis, normality test. So this week we will learn about normality test and correlation test, all right? So for normality test, from the words itself, you can see that we are testing whether the sample data or the variables from the sample data shows normal distribution, all right? So for example, we have normal distribution bell curve like this. If your sample data collected is showing normal distributed data, they will show it will show the bell curve like this. All right. And so how do we conduct tests to see whether or not the sample data is normally distributed? First, we have a few tests here. We have the normality test, what we call KS test, Kolmogorov-Smirnov, and Shapiro-Wilk test. And for normality test, we normally have the assumption for it. So for majority of the parametric statistic is assuming that the data is having normally distributed sample size, sample data. So how do you check? How do you check again? We use the test to see whether the sample data is normally distributed. So we conduct the exploratory data analysis here, what we call EDA, in SPSS software. So when you open up your SPSS, you go to Analyze, Descriptive Statistic, Explore, then you can carry out the EDA test. So I will not open up my SPSS software now because the school, Mr. Izam responded me that the school hasn't received the newest license for the latest version of SPSS. So my version has expired. So I'm waiting for the license code again from Mr. Izam. So if you downloaded the latest version of SPSS and the license has already expired, please wait, or you can call Mr. Izam to download the older version. Download the previous version of SPSS first, right? So let's get back. So we have these two statistics here. We have the two tests here, statistical tests here for conducting the normality test. First one, Kolmogorov-Smirnov. In short, we call this as KS test. All right, and Shapiro-Wilk test is SW. All right, so for KS test, we need to test for the differences in the shape of the two sample distribution. All right, so we compare the overall shape of the distribution. We need the data from univariate, one variable, and we need also continuous data. Same for SW test. All right. So both of these will test for normality. All right, normality of the sample data. So as a rule, we conclude, we need to remember this assumption or the rule of thumb. We conclude that a variable is not normally distributed if the significance value is less than 0.05. All right. So for null hypothesis, we have here. All right. The null hypothesis here. H naught here, the sample data is normally distributed. All right, that means we have parametric test here, and we will conduct Pearson correlation test. So that this we will cover in week 9 slides. So from here, for the KS test, we have the null hypothesis stating that the sample data is normally distributed. So when you reject, your hypothesis here, that means your variable is not normally distributed. So I will show you. Here. So when you conduct the test, right, you go to Analyze, Descriptive Statistic, Explore here, and then you move all your variables. Remember the one that you have already calculated the average or the mean for your variable, and then you move all your variables in dependent list. Then you click OK. So the result generated will show something like this. Yeah, from KS test, here you check significance value. For SW test, you also check the significance value here. All right. So if you have the significance value less than 0.05, that means you reject. Yeah, reject the null hypothesis of normal distribution. So you make the conclusion or you make the inference saying that the sample data variable from the sample data is not normally distributed. All right. Right. So next, so in summary, if your data meet the assumption of normality, yeah, if the significance value is greater than 0.05, that means you do not reject the null hypothesis of normal distribution. That means your data meet the assumption of normality. So whereas when you reject, when you have less than 0.05, the significance value is less than 0.05, that means you need to reject the null hypothesis, saying that it is normal distribution. Right? Please give me 1 minute. All right, thanks for waiting. So going back to our slide here, we also can test for normality using the plots. This will be extra. If you would like to learn for your own knowledge, you can message me. I can send the relevant material for you to learn about the QQ plot here. All right. So for data that can be considered normal, we also check its skewness and kurtosis. All right. That will be in our slide number 9 and 10. Right. So I will cover that in slide number 9 and 10. So I hope this slide is in your slide as well. If not, you can screenshot it here. So this will be your reference when you conduct the test in SPSS. All right. So this will be the summary. So for KS test and SW test, if you check the significance value here, if it is greater than 0.05, we conclude that the data is normally distributed. So if we reject, if it happens to reject the null hypothesis, when we have p-value less than 0.05, we conclude that the data is not normally distributed. Same applies to SW test as well. So we also check skewness and kurtosis for its normality. Right? So you can read the long story here, but in short, I will explain this in way easier method. So this is what we call skewness and kurtosis. So in skewness, you see this data, if the data show the graph like this, yeah, it is positively skewed. Yeah, you can see it is skewed to the right. And this one is negatively skewed. For kurtosis, you refer to the bell curve. Yeah, when the curve is higher, and then we have the leptokurtic here. So you can read the long story here, but in short, skewness and kurtosis are both important measures of the distribution shape. You can see from the note here, as some of you requested to add the subtitle, right? So skewness measures the asymmetry of a distribution. It generally measures the amount and direction of the skew, as you can see from the simple graphical graph here. All right. So for kurtosis, it measures the heaviness, heaviness of the distribution's tails relative to a normal distribution. So for normal distribution bell curve, it will show in this purple color. So if you have the positive one, you will see the one in green. Right? So in short, it measures how tall and how sharp the central peak is. All right, so how do we conduct the test here for skewness and kurtosis? Go to our SPSS software and check the box. Go to Analyze, and then Descriptive Statistic, and then you have the descriptives here, and then you select the variables. Remember, again, you need to select the variables which you have already calculated for the mean. All right, so we have 4 variables here. That means the color, material, design, and purchase intention here. And then you can check the box for mean if you want, standard deviation, maximum. And then remember, the most important thing here is to check the box for kurtosis and skewness. And then you can click continue and click OK. All right. So the result show will be looking something like this. Right. So at the graph here, the table here will show you the number, minimum, maximum, mean, standard deviation. Like the descriptive statistic that we learned before. And then for here, what we need to look at specifically important here is skewness and kurtosis. All right, so we look at the standard error and statistic here. The standard error is used when you want to calculate, when you want to calculate manually. But here, since you have the software, you can directly read the result and interpret the result. So for here, skewness statistic, you look at here, this one. So for color, we have minus negative 0.880. So for larger samples, you need to refer to this rule of thumb. So if it is normally distributed, the skewness value will range between -2 and +2. Plus minus 2. So if this value is within this range, that means it is this variable from the sample data is normally distributed. What if, for example, you have this one, minus 2.087. That is out of this range, out of this plus minus 2. That means the variable designed here has the sample data variable that is not normally distributed. All right. So how do you interpret for kurtosis? So for kurtosis, the rule of thumb is between +-7. All right. So for example, this one, color, material, and purchase intention. 3 of them has the statistic showing between this range. That means they are normally distributed. All right. So if you have the variable design here, refer to this one, statistic 8.633. That means out of this range, so you can conclude that for this variable, the sample data is not normally distributed, right? So you can also make a note at your slide there, so that you can refer back when you want to learn again. When you want to do a revision or you want to run the test in the future, right? So I will write this down. You can also jot it down in your slide. So for this one, you have minus 0.880 for color, and then you have minus 1.403 for material, and then you have minus 1.5 for purchase intention. So 3 of them you can conclude and interpret. Since the statistic value is within the range of minus 2 to plus 2, we can conclude that the sample data is normally distributed. Can you see my note here?
Yes.
Okay, you can add that in your slide as well, so that you can refer back when you want to do your revision or you want to test for your analysis. And what else we have? This one is for skillness, all right? Skillness interpretation. Then we have design minus 2.087 for design. So for skillness interpretation, since the statistic value is out of the range, we can conclude that the sample data is not normally distributed. So for kurtosis, you do the same interpretation, but remember the rule of thumb is plus minus 7. Right? For kurtosis, we have plus minus 7, and skillness, we have plus minus 2. All right. Do you have any question for me regarding the normality test? No? All right. Okay. So you can run your test now. You can use your SPSS to test for normality using the sample data I shared with you last time. All right. So maybe in 5 minutes, I will ask one of you to show me how to conduct your normality test, right? Okay. So maybe in 6:30, in 6:30, one of you can share me how to conduct the normality test, right? So if you have any question regarding this topic or your assignment, you can also raise your question now. All right. So regarding your assignment, my advice is to begin earlier, then you can figure out the problem earlier. Okay. All right. Can we have Xiao Hui? Can we have Xiao Hui here? Xiao Hui, are you there? No? Can we have Yap Mei Chin?
Yes, Miss.
Yeah.
I'm still running my SPSS software.
Okay. Anyone has already done using the sample data? Can we have Nuro Alia? Noor Alia? Are you there? Lydia Koch?
Yes, Miss. I'm also still running my SPSS.
Okay. So do you all know how to conduct the test? Dahlia?
Me too. I'm still running it, doctor.
Sorry?
I'm also still running SPSS,
Still
doctor.
running. Alright. Still running. Okay. So for this test, right? Please allow some students to enter. I do not have the request here. I've already allowed all. I do not have the request here. Can you ask your friend to maybe submit, try to enter again? I don't receive any notification regarding the intro. Anyone has already done your analysis? Alright, someone just entered. Sing. Are you there?
Yes, I'm here.
Yeah, can you show me how do you conduct your normality test? Yeah, you can share your screen. Maybe I need to stop presenting. Yeah, can you share your screen? Sing.
So sorry, doctor. Maybe I can't understand.
All right. Yeah, can you open up your SPSS software and then run the normality test?
SPS.
Do you have SPSS software in your laptop?
Yes, I have.
Okay, so do you have already import? Did you import the sample data into SPSS?
No.
So you can go to the drive. Do you have the drive? Which I shared in the WhatsApp group. Let me share to you again. Oh, sorry. This one. This drive, can you all see the drive here and open up? Yeah, download this one. Data for SPSS analysis. And then open with your SPSS software and then try to run the test here. Try to run the test here. This one. Skewness and kurtosis. Yeah, and also the KS and SW test.
Oh,
Okay, so if you do not understand, you can raise your doubts here because I'm here to help. Yeah. If you do not understand at this moment, it's alright, but when you proceed with your thesis in your next semester, it might be a trouble for you to not understand the concept. So at this phase, you can ask me any question regarding SPSS software. I'm here to help. And also, you can also email to me, right? Email to me. If I miss out your WhatsApp, then you can email to me because I receive quite a lot. You cannot download the folder. Can you download the folder? Others?
Yes, miss, we can download it.
Okay. Thank you, Faizano. So, try again, yeah? Who is that? Zhang Boyu. Yeah, try again. Try downloading it again. This one. Data. It's in SAV file. So when you open up, you need to open with SPSS software. Okay? Let me try to open mine because mine has already expired. I'm still waiting the license code from Mr. Izam. And what about others? All right, done. Okay, Sing Sing. So after you download the data here, and then you can open up using your SPSS. So here I have, yes, I can, yeah. This one here. Yep, I cannot run the test because my license has already expired. It's alright. Maybe we can conduct another activity. Yeah, for others, do you have any question conducting your analysis? If not, let me carry out this activity here. So after you have run the test, following all these steps here, and then you will get the result something like this. Yeah, you have your variables here, and then you have your skewness and kurtosis here. So when you refer to the result here, you refer to statistic, right? Statistics here, this one. So we need to check whether this statistic fall falls between the range, this one and this one. Okay, for skewness, we look at this range, plus minus 2. And for kurtosis, we look at plus minus 7. So for this one, yeah, if the statistic falls in between this range, we conclude that the sample data is normally distributed, right? Is normally distributed. So if it is out of this range, we conclude that the sample data is not normally distributed. So for this one, can someone tell me? Yes, can someone tell me? For this one, if your statistic is showing 0.895, do we conclude this one as normally distributed or non-normally distributed? Yeah, anyone? Anyone? No? Yeah, Faizano, can you try?
Miss, I think it's normally distributed.
Yes, correct. Yes, great. This one, yeah, can you give me your explanation? Yeah, why do you conclude that? Yeah, Faizano?
Maybe, Miss, because the number is between -1 and +1, something like this.
Yeah, correct.
That's
Yeah,
why it is normal.
yes. The way that you interpret is correct, but the range you use is not. Yeah, because for skewness, yeah, you always refer to whether it is falls in between this range, plus minus 2. Just now you say plus minus 1. Yes, some of the strict researchers, they use this range, but for the reference here, we use plus minus 2. So for this one, yes, Faizano, you are correct. This one is normally distributed. We conclude that the sample data is normally distributed because the value, the statistic value here falls between this range. Okay, so can you try again for kurtosis, Faizano? Can you try again for kurtosis? For this one?
Sure, Miss. Yeah.
Yeah.
Kurtosis, this one I think is normally distributed because the value is between -7 to +7. So it
Yes.
is normally distributed.
Yes, correct. You are correct. All right, well done, Faizano. So this one, as you can hear from Faizano, this one kurtosis, this one falls in the range plus minus 7. So we conclude that this variable here is, now the sample data is normally distributed, right? So let me add. For next hour, please, when we end this session, please switch to another link that I share in WhatsApp group. Okay, we have 10 minutes left. Okay. So for this one, can someone conclude for me it is or not normally distributed? Can we have Adeline Duo? Adeline, are you there? No? Okay. Can we have Mary Ling? Not there. Yin Jiehui. Are you there? Jiehui.
Yes, Miss.
Yeah, can you try this one? Can you conclude whether this variable shows that the sample data is normally or not distributed? Can you try?
The data for skewness is not normally distributed because the value is not between the -2 and +2.
Yes, correct. And then for kurtosis?
And the value for kurtosis is also not normally distributed because the value is not between the -7 and +7.
Yes, good job. Yeah, good job, Jiehui. Yeah. So this one is not normally distributed. This variable we can see from here. Okay. Can we have next one? Xuehan.
Yes.
Yeah, can you try for this one? Can you conclude? First, you check the skewness first. Is it within the range? Is it within the range? Within ±2? So this one is actually greater than 2. So this one is out of the skewness range here, because it is greater than 2. So from skewness, we say that this variable is not, is not. For skewness, this variable is not normally distributed. For kurtosis, this one is within, it's within the ±7. Okay, so for kurtosis, from kurtosis value, we say that it is normally distributed. So what happens now? So what happens when you have the result like this? So you need to conduct other tests to support your final conclusion. So for example, you can conduct KS test or SW test here. So you check if the result here, the significance value is greater than 0.05, we say that we do not reject the null hypothesis and the sample data is normally distributed. If it is less than 0.05, we reject the null hypothesis and we say that the variable from the sample data is not normally distributed. So if you have the result like this, you carry on, conduct other normality tests. So for this one, both of them falls in between the rule of thumb here. So we can conclude that this one is normally distributed. Okay. All right. So if you want to capture the result here, you can capture this one down and add to your slides. All right. You can refer back in the future. Okay. All right. Let's move on to week 9 content. So before that, let's move to another room. Let's move to another link that I share in WhatsApp, and then we can begin the class at 7. Okay? I'll see you there.
Okay, Miss.
Yeah, thank you.
Look at this! You can clearly see what appears to be skeletons through the window. It looks like...
Wow, this is hard to believe, but based on what happened yesterday, I guess they...
Huh? They're closer than you might imagine.
I'm also going to need an income. Otherwise, a peaceful life will be impossible. Any occupations in this world I might be successful at?
There's mugging, or better yet, murder!
Assassination isn't my strong suit.
If you're good enough to kill me, I don't think you'll have any trouble getting by.
Yes, good point.
No, it isn't! Huh? Hang on, someone's here. Probably to see Misaki.
Me? Really?
So, you're the assassin Zaki, right? I'm in trouble. I've got hitmen from another gang after me. You have to do something.
I'm not sure if I can. I'm in the middle of a pretty important job right now.
I'm begging you. Please, I need...
Very well.
Huh?
Your request is accepted.
Little punk! Where do you get off listening in?
It's a deal. If Polka's down to help you out, then so am I.
Huh?
Okay. What the hell is he thinking now?
If my info broker is correct, they should be sleeping in this building.
What kind of hitmen are they anyway? I mean, talk about careless.
They worked with a guy you offed named Jinba. These psychos, they take out their targets without mercy, and the families too.
They're his buddies, huh? An ambush? criticize, but you guys are a little wimpy for hitmen, you know.
Yeah, that's because we aren't hitmen. Truth be told, we're just a bunch of lowlifes, out to get revenge for our boss. All right, you guys finish her off. Huh?
I see. Really? Yes, I understand.
What the hell are you doing here?
I accept your request too. It's my pleasure.
Ah! You what? Fine then, die with Saki!
Oh, did I forget to mention it? Misaki there has become a zombie. A few holes aren't going to kill her.
Huh?
I'd imagine she's tougher than she's ever been.
What the hell are you anyway?
You hear me, Polka?
Oh, yes, I read you loud and clear. Is that how it goes?
Super. So how did you know this was a trap?
I didn't. I was merely carrying out a request. From the children.